Okay, so number one, let's do limit as x approaches 5, 50 minus 2x2 over 2x squared minus 9x minus 5, then 2 limit as x approaches negative infinity, square root of x2, no, sorry, square root of 4x6 minus 9x over x cubed, and 3 limit x approaches infinity, e to the x minus e to 2x. Okay, so here are 3 limits. So the first thing we do here is replace the x by 5, and you're going to get 0 over 0. And so we have a few choices. Either we factor or we use L'Hopital's rule. Okay, so I prefer using L'Hopital's rule here. It's much simpler. Derivative of the top is negative 4x. Derivative of the bottom is 4x minus 9. Plug in 5 here, you get negative 20 over 11. This one here, if you replace infinity inside, you're going to get infinity over infinity. So you could use L'Hopital's rule, but when you have a square root, it's always annoying because the square root doesn't cancel. So we're going to factor just like we did at the beginning of the course. Limit x approaches negative infinity. So square root of x6 times 4 minus 9 over x5. On the bottom, it's just x cubed. Then the square root of x6. So limit x approaches negative infinity is absolute value of x cubed. Don't forget the absolute value. 4 minus 9 over x5, x cubed. And since x is negative, so when you take out the absolute value, it becomes minus. X approaches negative infinity of negative x cubed times the square root of 4 minus 9 over x5 over x cubed. Okay, and now I can cross out the x cubes. And if it's infinity here, this becomes a 0. Square root of 4 over 1, which is 2, so I get negative 2. Questions?
Can you re-explain the part where you're taking it out of the absolute value sign and then you made it negative?
Here?
Yeah.
Why is there a minus?
Yeah.
Okay. Because when you take the square root of any number, the answer has to be positive, that's for sure. So this has to be positive, and to be sure that it's positive, I need to put absolute value. That's the first thing. Now, when I take out the absolute value, if I just take it out and leave it as x3, then this will be negative because x is approaches minus infinity. So that would be a negative number. So to make sure that this still stays positive, I have to put a minus in front. Because minus infinity becomes a positive number.
Okay, so you want it to stay positive.
Yeah. If what's inside the absolute value is negative, I need to put a minus when I take out the absolute value.
Is it okay if we just did, like, I had put the absolute value and then just had a minus in front of the absolute value?
No, that's wrong.
Okay.
No.
Okay.
Okay, you really have to write. If you put a minus in front of the absolute value, it's completely wrong. Okay, now infinity here, so I get e to the infinity is infinity minus e to the infinity is infinity. And so what do I do here? What do you suggest?
Could you factor out an e to the x?
Very nice. Okay, so it's equal to the limit x approaches infinity. So let's factor in e to the x times 1 minus e to the x. That's the same thing. And if you plug in now infinity here, you're going to get e to the infinity is infinity times 1 minus infinity is a negative infinity. And so infinity.
Wouldn't it, sir? Wouldn't it be oh, never mind.
Okay. And infinity times minus infinity is minus infinity because plus times minus is minus.
Sir,
Yep.
can we do it another way, like multiplying by the conjugate?
Did you do that?
Yeah, and I got this. I got negative infinity.
If you multiply by the conjugate here, okay, maybe. Yeah, it's possible. Yeah, it's and you factor it. Okay. I didn't try it like this, but if you say so, okay. Number 4. Limit as x approaches 3 from the right side. Absolute value 6 minus 2x over square root of x minus 3. So if we plug in, of course, 3 on top and on bottom, we get 0 over 0. And this is equal to the limit as x approaches 3 from the right. So I'm going to get rid of the absolute value. So if x is approaching 3 from the right, that means that x is bigger than 3, this is bigger than 6, and so this will be negative. Okay, so what's inside the absolute value will be negative. And so if I need to take out the absolute value, I need to put a minus in front. Okay? Now I'm going to extract a negative 2 here. And I will get 2 times x minus 3. And on the bottom, I will have square root of x minus 3. And if this is x minus 3 power 1 over x minus 3 to the half. So this is just 2 times square root of x minus 3. You divide, that's what you get. Plug in 3, you get 0. Number 5. Limit x approaches 0. So let's say 8x over sine 4x times cos 5x. So if you plug in, you get 0 over 0. Okay, so we could do L'Hopital's rule, but you're going to end up with a product rule on the bottom. You could do it if you want. Let's do it. Limit x approaches 0. Derivative of top is 8. And on the bottom, we have derivative of sine is cos 4x times 4 times cos 5x plus derivative of, so sine 4x times derivative of cos, which is negative sine 5x times 5. Okay, so if you plug in 0 here, you will get 0. And here you'll get 1, 1, 4, you'll get 2. Okay, no questions? Okay, let's do a continuity question now. So number 6. So let's say f of x is equal to, so a piecewise function, x2 minus 4 over x2 minus x minus 6. If x is less than or equal to minus 1, then 1/4 x plus 1 if x is between -1 and 5, and 1 over x2 minus 10x minus 24 if x is greater or equal than 5. Okay, so this is my function, this is f of x. Okay, so the question is, find and classify all discontinuities of f. Okay, so I want to find all values of x for which the function is discontinuous, and of course tell me if we're talking about a jump, a removable, or an infinite discontinuity. Okay, can you tell me which values of x we should inspect for discontinuity? Any idea?
Well, there might be an infinite discontinuity for the third function.
Okay, let's start with the first one.
There's going to be a removable discontinuity.
But I'm not there yet. Just I want to see the potential. So let's write down the potential values of x where there might be a discontinuity.
-2
Where?
for the first function.
-2. Okay, so let's look at this first. If you were to factor this, you would get x minus 2, x plus 2, and on the bottom I would have x minus 3, x plus 2. Okay, and this one here, if I would factor, I would get 1 over x minus 12, x plus 2. Okay, so definitely I have to inspect -2, 3, 12, and -2. Okay, so first thing, x equals -2, obviously. How about x equals 3? Is that a problem?
Yeah.
No,
Yes or no?
no, because it's not in the function. It's not part of like the piecewise.
It's not a problem because it's true that it can be 3, but anyways here, I'm not affected. X is less than -1. Okay, so we're on the left of -1. So 3, x is never going to be 3 in this function. Okay, so I don't need to be preoccupied with 3 here. So the other place I need to be preoccupied is with -1. Because at -1, this function connects with this one. I have to make sure that the connection is smooth. Okay, or at least it connects. There's no jump, there's no hole. So let's check what happens at x equals -1. Then, of course, here there's no problem, there's no denominator, and I have to check at 5 now. What else? 12. So there's 4 values of x where I need to check for continuity in this function. It might be continuous, it might not, it might be jump, removable, infinite, I don't know. Okay, so let's do it. I'm going to do it fast because class is ending in a few minutes. So I'm just going to go fast through this, okay? So let's go with x is equal to -2 first. So at x is equal to -2, what do we have? So I will do the limit as x approaches -2 of f of x is equal to the limit as x approaches -2. So it was a top function, x2 minus 4 over x2 minus x minus 6, which is the limit as x approaches -2 of x minus 2 times x plus 2 over, on the bottom I had x minus 3 x plus 2, cross out the x plus 2, plug in the -2 here, I get -4 over -5, so I get 4/5. So the limit exists. Good, so it is continuous?
No, we need to check from the right.
No, I didn't. I did left and right at once. There's no problem with left or right here. It's the same.
Oh, okay.
I get 4/5, so the limit exists. So it's continuous?
We have to find the f of -2.
Very good. So now I need to find the value of the function. F of -2, and let's hope that it is 4/5. Okay, now f of -2, if I plug in -2 here, I will get that it's not defined. Okay, the function is not defined at -2, and so if I were to maybe represent what's going on here, so at -2, 4/5, it seems to go like this. So there's a hole at -2 4/5. So it is not continuous. So there is a removable discontinuity at x equals -2. All good? Let's see, x equals -1 now. Okay, so we have to do the limit from the left and the limit from the right. Okay, so from the left, it was this function here. And on the right, if you remember, was 1/4 x plus 1. Let's plug in -1 here. I get 1 minus 4 is -3. And on the bottom, I have 1 plus 1 is 2. 2 minus 6 is -4. So -3 over -4, I have 3/4. And if you plug in -1 from the left here, from the right, I'm sorry, you get -1/4 plus 1 is 3/4 again. Good. So the limit exists. And now I need to check f of -1. Okay, so f of -1, I'm just going to go back here. When x is -1, my function, this is the function in effect. So I need to plug in -1 into here. So f of -1, you will see -1 squared minus 4 over -1 squared minus -1 minus 6. You'll get 3/4 as well. Good. Okay, so f is continuous at x equals -1.
Sir,
Yeah,
you could have done that for -2, like from the left and from the right.
I could have, but I didn't need to because it was the same function. Here I did left and right because on the left I have this function, on the right I have this function.
Okay.
X equals 5 was my other one. So at x equals 5, also there's a connection. Limit x approaches 5 from the left and limit as x approaches 5 from the right. I know I'm rushing, but I just, I want to finish this. Plus 1, and then 1 on the right is 1 over x2 minus 10x minus 24. So if I plug in 5 here, I get 5 over 4 plus 1 is 9 over 4. And if you plug in 5 here, I get 25 minus 24 is 1. 1 minus 50 is minus 40. So negative 1 over 49. So definitely not the same. Okay, so it is a jump discontinuity. Okay, so limit as x approaches 5 of f of x does not exist. And there is a jump discontinuity at x equals 5. So from the left it's 5 over 4, and from the right it's negative 1 over 49. Okay, and when is it, where is it equal? At here, because the 4 equal here, so the dot is full here. So as you see, there is a jump discontinuity. Any questions so far? Okay, last one at x equals 12. So this is the limit as x is approaching 12 of 1 over x2 minus 10x minus 24, and that is equal to limit x approaches 12 of 1 over, if you factor x minus 12, x plus 2, and you see that you get 1 over 0. Okay, so right away I know that we're going to have an infinite discontinuity here. So either it's going to be a vertical asymptote. Okay, so it's either plus infinity, minus infinity, or does not exist. Let's do both sides. 12 from the left, x approaches 12 from the right of f of this. So in this case, 1 over 0, 1 over 0. If I'm approaching 12 from the left, this will be negative. This is always positive. So this is negative, so I will have minus. And if I'm approaching 12 from the right, this is positive, and positive is positive. Negative infinity, positive infinity. So limit as x approaches 12 of f of x does not exist. So there is an infinite discontinuity at x equals 12. Vertical asymptote. From the left, minus infinity. From the right, positive infinity. And that's what it looks like. And that completes this exercise.